Perl6 because I like it. I really do. I think it's great, and I think it's a brilliant language that it's getting a lot more people using it. It's getting a lot more interest. I spend a lot of time on IRC and Twitter and Stack Overflow, and there are more new, different names turning up, getting interested in it. And also, Mohammed's just started doing it. He's already put in like 5 pull requests on some of the documentation, so everything's going to go through. But I had one idea for a talk, and then I ended up not doing it, so I got halfway through writing it and realising that testing it was going to be a right pain, and I was on holiday, so I'm shelving that for a little bit until I can test it. So instead I've put something together about operators and meta-operators. Now this is a question that I think I wanted to cover, which is, what is an operator? And the POSIX documentation simply defines it as an operator is just a subroutine with a funny name. Operators in POSIX and subroutines are pretty much interchangeable. You can call operators as subroutines directly rather than like put them into things, and you can use subroutines in situations where you would normally use an operator. It just works, and I'll explain how as we go along. So POSIX has 5 types of operators that are defined for it. You've got the infix operator, which sits between 2 operands, in this case plus. You've got the prefix operator, which sits in front of an operand. In this case, we've got the Boolean negation operator. That way, yeah, some brain part. You've got postfix operators that sit afterwards. So in this case, we've got the postfix increment operator, nice and simple. Then you've got the circumfix operator. So here, the square brackets are the operator. So that's an operator that is basically the array constructor. And you can create constructors like that and stuff. We'll go into that in a second. And then you've got the post-circumfix. I love that one. Which is, in this case, the operator will receive 2 values. The first one being the thing on the outside, on the left-hand side of our post-circumfix. And then the second value being the 0. So it's going to be at A and 0. So you can create your own things for referencing data within objects and stuff. And pretty much every single operator in Perl6 is defined using these things. There are a few special cases, but mostly they are actually defined using these things, like so. You can create an operator and it's just a subroutine. So for an infix subroutine, you use the infix colon name convention and prefix postfix suffix and this kind of stuff. And that's how simple it is to create an operator in POSIX to do whatever you want. Important thing to note, and you'll see it happening on the post-circumfix and the postfix, you can't have a space. So I'll just make it note about that. You can't have a space between the operator and the thing that it's operating on. You'll note here on the circumfix, when you're defining it, you give it the 2 values that you want. They can actually be the same if you want. So you can have the opening and the closing operator being the same thing. And the same for the post-circumfix. It's just that the post-circumfix knows that it's going to take an additional value. This could be a list. In this case, I'm looking for a scalar value, but you could have a list going into there as well. There's all different types of stuff. Because these are subroutines, you can also use the Perl6 multi-method thing, so you can have the same operator working differently depending on different circumstances. And you've also got the availability of all the Perl6 signature stuff, which I've talked about on occasion before. All of the functionality you've got in standard POSIX is available for operators, which is good. You can also do, and because of that, you can do operator overloading, which in Perl5 is a pain in the butt and generally really dangerous thing to do because Perl5 doesn't have types, but Perl6 does. And this becomes really simple. So here I'm defining a vector role, which can become a class as well, because roles basically, class is interchangeable. You can do different things with roles, but you can also just instantiate them. And then down here I'm defining infix plus, and I'm saying, okay, and if I use plus and I pass in 2 vector objects, I'll create a new vector object of the vector addition of the 2 objects. So that's how simple it is to make how simple it is to operate our overlay. I'm realising I'm talking way too fast. I don't have enough time. Maybe, I can't remember. I'm sure I talked slightly slower when I tested this the other day. Yeah, so very simple to overload an operator. But of course you can come up with some issues. So in this case up here, this is one of my favourite operators. Whenever I'm messing around, I create this operator again, which is the D operator. Anybody who's done any Dungeons and Dragons or role-playing or anything like this should know the D operator. You give it two numbers. The first one is the number of dice you're rolling, and the second one is the size of the dice. The nice thing with the D operator is it means you can roll like 5-sided dice and 17-sided dice and any other dice that you really feel like. So in this case, I want to roll one 6-sided dice and then multiply the value by 100. But unfortunately, it's gone slightly wrong, because it's given me back a number of 578. So unless my 6-sided dice came up with 5.78 as a result, something's gone wrong. Of course, the problem is that it's done the precedence thing, so it's actually done 6 times 100 and rolled a 600-sided dice. Like I said, this is the problem with my D operator, it doesn't know what actual dice sizes are, and thus has given me the number of 578. But it's very easy to define the precedence of an operator. You use in this case I'm using is tighter. What I'm saying is that I want the precedence of my D operator to be tighter than the precedence of the multiplication operator. And now I run it, get 300. Now, I ran it a few more times just to make sure it worked, but it really does. So that's great. And I just remembered I had more slides than I thought I did. So there's 3 options for precedence. You can define an operator as being tighter than an operator, you can define it as being looser than a different operator, or as an equivalent precedence. And I think you can actually change them as well, so you can have multiple ones to sort of really dilly it in there. But generally, one of those should be enough to get it the precedence where you want it to work. That's great. But then you have the next option. So in this case, what I wanted to, I put in a note here because it wasn't working right. Why isn't it working? What I wanted to do was roll 3 6-sided dice, and then roll a dice that big. So it's like roll 3 6-sided dice, that comes with 11, then roll an 11-sided dice and get a number like that. Because I'm crazy and I like playing around with this, and I needed a contrived example. But what it's done is actually do it the other way around. It's rolled my 1d3, and then used the number from that, which was a 1, to roll a d6, which isn't what I wanted, because I hadn't defined any associativity. So in this second option, I'm saying that it's right associative, because by default operators are left associative. So in this case I'm saying I want it right associative, roll it again, probably didn't need to roll it again, and this time it rolls the 3d6, gives me a 12, and then rolls that and gives me a 7, so awesome. So not only can you define precedence, you can define associativity, and there are 5 associativities, not just left and right. You've got the non-associativity. So this can be useful if you don't want your operator to be chainable. If you don't want to be able to write A op B op C, you can get it so that it will compile time error if you do that. So if it doesn't make sense, you can tell the compiler, does not make sense to do this, does not compute. It's kind of cool. But you've also got the chain operator. So chain you want to do with Boolean operators, and what the chain operator will do is it will do test on your first 2, and then again here, and then test on your second 2, and then test on your third 2, and then test on your fourth, if you keep going. And this is how in Perl6 you can write a test of 1 is less than $x is less than 3, and it works. You don't have to test $x against 1 and $x against 3, you can just write it as one string. Or, which is kind of cool. Hello.
Does it still then only evaluate the middle one once?
No, I think
it's actually evaluated twice.
Though actually, they might be set up as listeners. But this is from the docs, okay? That's literally copied straight from the docs. So yeah, it will be evaluated as well.
It evaluates the ones. It evaluates the instance ones.
Cool. Yeah. And then finally, you've got the list operator, and what that will do is it will actually take all your values and pass them in as a list, and then you're then you can work on them as lists, and that can be quite useful when you're dealing with like ranges and stuff. And so I've been doing some things with there's a module I've been working with on and off to have set operators work on ranges without turning the ranges into lists. But yeah, left is the default. So once you've got an operator in place, you can now start playing around with the meta operators. The meta operators are awesome. Now, I actually used one a little while ago, which is the reduction operator. I'll start on. So the equals operator has many hats in Perl. One of them is the assignment, where you can pretty much any operator you can immediately make into an operator equals thing and use it as an assignment, and it just works. So like for instance, the plus vector one, I was testing this one and it does work. You create your vector, and then you do plus equals another vector, and your first vector is now set to the new value, which is good. The reduction meta operator, like I say, one of my favourite things, because whenever you want to do reduce a list, you just can do it like this. Put square brackets operator in front of the list, and it goes through it. And I'll zip back a couple of slides. So you see I'm using it there. I didn't explain this code before, but I'll quickly explain it now. So what I'm doing there is I'm saying reduce using a plus, so I want to add up all the values of, I'm taking a range of 1 to the size of my dice, and then I'm calling the roll function, which is one of the two functions for picking a random number from a list. The two of them are called pick and roll. Pick will not return the same value from the list twice, and if you tell it to pick more values than are in the list, it will only return you all the values of the list in a random order. Roll doesn't care. So if you give it 10 items but tell it to roll 100, it will give you multiples of the same value and stuff. But that's the reduction meta operator, and then takes that list of things, slips them all together, and gives us a final result. Back to that was bonus slide. Can't see the bonus slide. Yeah. Zip operator. Nice and simple. Gives us that thing that you can do where you take here's a list, here's another list, and I'll apply the operator to each item. I take the first item for each list, apply the operator, second item, and give me a list back of the results. If you call it without an operator, then it defaults to the comma, because comma is an operator that creates a list. So what that will do is it will end up giving you a list of lists. So first item will be the first two values, second item will be the second two values, third item, third two values, and so on. As soon as one list runs out, it stops looking at the other list. This can be quite useful if you're using, if you've got an infinite list on one side. Very useful if you've got an infinite list on one side, otherwise it will go badly. Cross operator, I have to make that slightly smaller because as you can see it's doing cross product across all of our lists. Again with an operator, again, defaults to comma if you don't give it any operator. The reverse operator can be kind of useful sometimes, especially if you're dealing with sort of fixed lists and doing stuff with lists and things. And what it will do is it basically just reverses your operation. Flips them around. The sequence operator I only really learnt about when I was looking up the code for this, and I figured I should put it in here. And what that does is it tells the compiler and all the other bits in the VM to not modify this test at all, not modify this sequence of operations. It will always run the sequence of operations as you've given it. It will not go, well, this will always evaluate to true and I'll just make it into a true, which it can do. It will always do that sequence of operations. It's possibly useful, but generally I don't think you get it. There is also the hyperoperators, but they were very, very complicated, and I didn't think I'd have the time to cover them. Or I think I probably would have done because I've talked about hyperoperators. Hey, 5 minutes.
I've got a question now for you.
Well, I've got one last slide. I'll do my bonus slide. Or do you want a question on this?
It's about the assignment.
Yes.
So it seems like all the other ones basically return a new thing, whereas that one might mutate existing something.
Well, it will.
Or thing.
So it won't mutate the existing object, but it will change what the object is pointing to, because that's a container for another thing, so it will change what's in the container that it's pointing to. So the old object will still exist, and then we'll probably get garbage collected if depending on how you've done bindings and stuff. But yeah, it's not a mutator as stuff. At some point I need to fully understand and maybe then do a talk about how Perl deals with containers and boxing and stuff.
So I was thinking, because if you want immutable objects, would this come just no? I'm just gonna.
No. That will like I say, that be a new object. It's just the pointer to it is the thing's pointing to the new object.
If you want a mutable version, you can define your operator equal on your own for your classes. If you really want to
you can override for operator if you want to do that. Bonus slide. I just thought I'd throw this one in there. You can totally use emojis as operators if you want to, because why wouldn't you? POSIX fully Unicode compliant, so let's just throw it in there. A quick explanation of what this one's doing. All is a, what are they called again? Junction. Yeah. So that evaluates all the different values and stores them as a quantum position state until you look at them. You look at them by calling the Boolean cast operator, or method, which in this case is called so. There's two Boolean cast methods. or no, 2 operators, 1 method. So and question mark. Question mark is lower precedence than so, or possibly no. So what this is basically doing is testing everything in that is true. Well, it's testing everything and returning whether or not it's true, and yeah, so I've got a few minutes. So questions?
Can you go back to the meta-operator slide?
Yes.
So, with the exception of reduction, these are all infixes.
Infixes, pretty much. Yeah.
Can they take post-cert infixes or just infixes?
So I've not tried it with per-circle
R dot
fixes.
square bracket.
I think, right, so one of the things is they can take functions. If you've got a function that takes 2 or more parameters, you can basically ampersand it and throw it into the space. And that works for the reduction operator, and I was testing that today. Like if you have a function that takes three parameters, it will do 3 and then it will do the next 3 and then it moves along. The zip and the cross ones though don't. You've got to have two parameters on those. I've tried those ones. I have no idea what reverse. I think reverse will go like, what the hell do you mean when you try some of the
Post-circle fix has 2 parameters.
Yeah, no, yes. I've not tried it. It would probably work, but it would have to be a very special post-circumfix operator, I think.
I'm just thinking, you know, have the array on the right and the index on the left.
Yeah.
Yeah,
R dot square bracket.
It is all, there is more documentation on this on the POSIX documentation things. I highly advise you can have a look or come and ask me questions. It's all good. I've got a bunch of books upstairs. Any other questions? We all good?
Yeah, it's not.
Oh, yes, sorry.
The vector addition method that you had a bug in it.
What was it?
I was asked if v2.y plus v2.y.
Oh, God, yes.
And the is tighter.
Yeah.
I was wondering, is that fractionally tighter or is that the next precedence level?
Fractionally tight.
Fractionally tight.
Okay. So it doesn't then switch with a bunch of other operators.
No, it just sneaks in just like before, just after.
you can probably binary search your way to the
Yeah.
as you want.
Now, one thing I would say in advance, like the final note, is that right now defining your own operators does give you a little bit of performance hit at startup, because you're basically poking stuff into the compile, like the abstract syntax tree and stuff. Once your code's running, you know, so if you've got a long running bit of code, like a pro web service or something, then using your own operators in them isn't that much of an impact really. It's just, it kind of opens up the compile steps. And pre-compiling things in libraries probably helps with that. Cool. Any more questions?
Thank you.